Welcome to the THS video on circuits. The video is covered by the THS code PH03, which covers all the electricity units on the new THS core website. In this video, I will be covering the different types of circuits, the circuit symbols and what they do in relation to the circuit. I will also explain the potential difference, resistance, current and electrical charge, what they are and the effect they have inside the circuit. Types of circuit. Part 1. There are two types of circuit, parallel and series. Let's look at series. Components that are connected one after another on the same loop of the circuit are connected in series. The current that flows across each component connected in series is the same. If one component in the circuit breaks, then the others won't, as their current or circuit is broken. A way to think of this is like a single track railway, and each component is a railway station. The current flows in a loop much like a train between each station. If one station were to come out of action, the railway track, the wires, were to break, then the train couldn't continue, because there's no way for the current to go round, or the train to go round. An example where a series circuit is used is on traditional Christmas lights, which meant that if one bulb went out, all the lights wouldn't work. In the modern day, Christmas tree lights are in a parallel circuit. In a parallel circuit, the train goes to each station separately. So if one station were to be removed, then the train can still travel to the others, because there's still rails or wires to get to them. This meant that in the case of Christmas tree lights, the rest of the lights will be able to This means that in the case of Christmas tree lights, the rest of the lights will remain on even if one bulb goes. In a parallel circuit, each component is on its own loop. Part 2. Circuit symbols. A cell supplies the electrical energy to the circuit, and a battery is when multiple cells are put together. A cell has one singular big line, little line on its symbol, whereas a battery is two cells connected by a hyphen or a dash. There are two symbols for a switch. On switch, which is where the line is connected to the two dots, or the two ends of the wire, and an off switch, where the line is not connected, so the current can't flow through, much like in a series circuit like we were on about earlier. These two you might recognise: a bulb, which is what we use for lights, and a buzzer, which is a component that makes a sound when the electric current passes through it. An ammeter is used to read the current of a circuit in amps, because current is measured in amps basically, hence the fact ammeter. A motor is something that moves when a current is passed through it, much like they do in electric cars. Now, these symbols are quite self-explanatory, with the ammeter being a big A and the M being and the motor being a big M. A resistor is something that reduces the current in a circuit because it sort of pushes against it. Like if in the riot situation, a resistor acts much like the police against the rioters to stop them from coming further in. A variable resistor is something that you can have the resistance altered constantly, dependent on the different variables like current. A diode is a discrete component that allows current to flow one direction only and prevents backflow in the circuit. An LED is a diode that emits light. A fuse is a wired component that when a certain amount of current is passed through it, in a power surge for example, the wire melts and breaks the current or circuit. This is designed to prevent the surge in electricity from damaging your device. A thermistor is a component that changes resistance dependent on the temperature of the component. LDRs, or light dependent resistors, are used to detect light levels, for example in automatic streetlights. A voltmeter is used to determine the potential difference of circuits in volts. Part 3. Current and charge. There are two types of current. AC, which stands for alternating current. This means that the current changes direction rapidly and constantly. AC current is used in the main electricity, but the current changes so rapidly that it isn't even noticed. The other type of current is DC. DC stands for direct current, which is when the current flows in one solid direction. The electrical current is the flow of electrical charge. A current has the same value at any point in a single circuit closed loop. There are four ways, in effect, that you can work out the current of a circuit. The first, current equals electrical power divided by potential difference. Current can also equal charge divided by time. Current can equal energy transferred divided by time times potential difference, and current can equal the square root of electrical power times resistance. Here we see all the equations represented in equation triangles. To use these, you cover up the thing you're trying to find out. If the remaining two are on one over another, then you divide, like you would in a fraction. For example, finding current in the first triangle, if what you have left is all on the bottom, then you multiply them. For example, finding charge on the triangle at the top. Part 4. Potential difference and resistance. An electrical current flows when electrons move through a conductor, such as a metal wire. The moving electrons can collide with the ions in the metal. This makes it more difficult for the current to flow and causes resistance. One way to look at this is by showing the electrons as year 7s in a corridor. They have lots of energy and dart from one place to the next and can easily weave around the year 11 students, the ions. As the wire heats up, the ions gain more energy and start to move. This is when the year 11s get a little bit more boisterous and start moving between lessons. This movement makes it harder for the year 7 to move through the corridor, and sometimes they collide with each other. This is known as resistance. Resistance can be calculated in the following two equations. Resistance equals electrical power divided by current squared, and resistance equals potential difference divided by current. A potential difference in an electrical component is needed to make a current flow through it. Potential difference in a circuit is normally provided by a cell or battery. Potential difference is also known as voltage. Potential difference can be calculated in the following three equations. Potential difference equals charge moved. Potential difference equals energy transferred divided by charge moved. Potential difference equals electrical power divided by current, and potential difference equals current times resistance. Part 5. Circuit equations. We have looked through the specifications for OCR, Edexcel and AQA exam boards, and we have designed a small poster for all the equations for the circuits topic. It's available free from the THS store, with the link in the bio. The name is Circuits Poster, brackets PH03. Part 6. Practical applications. We have three main examples of where circuits are used. The mains are sending electricity in a series circuit around your house, which powers your lights, your plug sockets, so your telly, your fridge. Also, in your house there will be a circuit board that contains fuses that can stop damage from electrical components in your house, such as your mobile phone. Also, circuits are used in Christmas tree lights. This video is covered by the resource code PH03, and you can go to the THS store to find resources available to do with this topic. Thank you for watching.